Okay, so let's talk about domain and range. Let's identify those very quickly. Domain, excuse me, domain is simply referring to your x-axis. Okay, that's all it refers to. And what we'll do is we use a vertical line test for this. Okay, and I'll get into that in just a second. I just want you to have some terms here. Range refers to your y-axis, and for testing for this we use a horizontal line test. Okay, so if I have, and I'm going to zoom this out and put this in the upper left corner here just because we want to be able to access that. So if I have excuse me, if I have a parabola that has a minimum value at -4 and the x value is at 1, so I have it right here, and it goes like this. Okay, there we go. What I want to do is I want to find out what is the domain and the range of this particular quadratic function. Okay, so I want to find the domain. Basically, what I'm looking for here is for what values does the function exist, and this is where we use that vertical line test. So let me go ahead and draw out a vertical line. Okay, so we're going to draw out a vertical line here for a second, and let me just put it over here. Okay, so there's my vertical line, and what we want to do is we want to just run this vertical line across or run it along the x-axis and see if this vertical line, remember this vertical line is going to extend for infinity in both directions, top and bottom, okay, so up and down. And what we want to really check out here is, does the vertical line touch this graph no matter where I go on the x-axis? And the answer is going to be yes, because if I go here, because I have these arrows right here on the end of the function, it means that this goes on and on and on, and this goes on and on and on forever. So because it goes on and on and on forever in that direction, and it's always getting a little further, 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 it means that this function exists across the entire x-axis. Okay, so it doesn't matter where I go on this x-axis, this function will be, this vertical line will touch that function somewhere. Okay, so my domain in this particular case is going to be all, holy moly, that's a fat marker. Give me 1 second, let me back that off for a second. Is going to be all real. Okay, hold on. It's going to be all real numbers, okay? Because it's basically everything across the entire x-axis. So now let's go to, I'm going to put, so that's for the vertical line test, so I'm going to put that over here. Now let's look at our range, which deals with the which deals with the y-axis, right? And so what we're going to do is we're actually going to do a horizontal line test. I'm going to do this one in blue. And so here's the blue. So that's vertical, or sorry, horizontal. And so now I'm going to grab that and I'm going to go, okay, well, there's no graph down here. So it doesn't exist here, doesn't exist here, doesn't exist here, doesn't exist here, exists right there, begins to exist right there at -4. So I know that my range begins at -4. And where does it go to? Well, it's going to go to, well, those arrows continue. So if I just bring this line up, these arrows are both going to move forever and ever up into what we would call infinity. Okay? And so what we'd want to do is we'd want to have bracket and then parenthesis there. Okay, bracket meaning it's inclusive, parenthesis meaning it's exclusive. -4 is where the graph begins, and it goes on forever. Okay, and that's how you solve for domain and range. It's pretty much that simple. You're just using some you're just using a horizontal line test for the range, a vertical line test for the domain, and you're just seeing where it exists along where it exists in that the real plane. Okay, some of you may get some different ones. They may be inverted, they may be sideways. You know, just do those vertical and horizontal line tests, and you have to think of this in terms of these graphs go on forever out into the graphing plane, the Cartesian coordinate plane.